Now here is a man, he has some stuff. He wants to take it, but he is not able to. Why? Because the size is very high as compared to the capacity of the truck. So what are the packets? Packets are nothing but the envelope. That is the data you are transferring from sender to receiver. You are using the TCP IP network, and these packets or these envelopes or these content are sent according to the network bandwidth, and there are so many things involved. That is, this is the content as I just told you. Now this, you can consider this as a whole data, whole content. But before the file is sent across the internet or a network, that is using the TCP IP, it must be broken down or divided into series of packets. So this is the data. The packet will be formed when you divide it according to the requirement. So packets are essentially, these are the smaller parts or chunks of a larger file, and they will be transmitted individually. For example, this is an image and this is very large. You cannot send it at once. So you have to divide this into different pieces. This is how we divide it. This particular data in this example, we have divided it into say 291 separate sections or pieces, and these 291 are nothing but the packets, and this will be transmitted from sender to receiver. But it depends on the network. The network can have different bandwidth. So this, you may have say 100 packets, you may have 500 packets. So it is not fixed that you have to do 291 also. That's what I am trying to highlight here. A packet is simply a content which has to go from sender to receiver. And every packet is organized normally, typically into 3 sections, 3 parts. We call it as IP, we call it as a datagram. So the first part of the data packet structure is header, second is payload, and third is trailer. So this header contains instructions about the data being carried out by the packet. So these instructions include various things. For example, length of packet. Because some networks have fixed length packets while others rely on the header to contain this information. Right? So in the header only you can have length of packet. Along with this, we have the synchronization. A few bits that help the packet match up to the network. So synchronization also is given here in this first part, which is the header. Packet number, which packet this is in a sequence of packets. So packet number will be also there. Then you have a protocol, because on networks that carry multiple types of information, the protocol defines what type of packet is being transmitted. Email, web page, streaming video. Then the destination address where the packet is going, originating address where the packet came from, right? This all is under header. Then we have the payload. This is also called as the body or data of the packet. This is the actual data that the packet is delivering to the destination. If a packet is fixed length, then the payload may be padded with blank information to make it the right size. So this is the example of a proper data actual going. So this is the padding. If the data is less, the padding can be done with the blank information. So this image, for example, this image which we discussed, this is the actual 1001 data that will go, and this will be under payload. The third part is the trailer. You can also call it as a footer. This typically contains a couple of bits that tell the receiving device that it has reached the end of the packet. And this trailer may also have some type of error checking. For example, the most common error checking used in packets is CRC, the cyclic redundancy check. So this will tell you how many bits are damaged, or they are not reached, or they are out of order. So these are 3 parts.